moment with respect to point O. You see this point, the green one? So, what method should I choose? The lengthy cross product, mathematical method, or method of moving forces? Which one is easier? Moving forces, right? The cross product will give you exact same result, but it takes longer time. Right? So, in order to do method of moving forces, what should I do? Step one. Decompose each force into X and Y if you're doing 3D Z component, right? So, let's start with this guy. This is already decomposed. It's in the X direction. See that? So, step two. What's the step two? Move it such that you get the moment arm. So, where should I move it? Along this line of action. Where is the line of action? This way. So, I can either move it this way or this way. Which way should I move it? To the left. So when I move it to the left, at this specific point here, you see, it becomes normal to point O. So you find the effective distance or moment arm. Step three, moment arm times the value of force component is the value of contributed moment to the resultant moment. So if I write MR with respect to point O, the first contribution comes from this guy, which is the moment arm. What should I write for moment arm? From here to here.
6 cosine 30.
Thank you. 6 cosine 30 degree times, this is moment arm, times the value of component. What's the value of component? 200 pounds. Positive or negative? So this is your R. Finger goes to R. The palm should show the direction of force. The finger, your thumb, would show the direction of the moment, which is positive, outward. So that's positive. Now let's go to the next component. This guy. This one, we have to do a step one. Step one, decompose it into the XY component. So first, I decompose it, this is green. This is the Y component, which is 200 times cosine 30. And the X component is, thank you, 300 sine 30. Right? Decompose the vector into XY component. Step two, move. So let's start with this guy. Move it. Where should I move? This component. To the right, to the same place. So that you have the same moment arm. So the same moment arm, 6 cosine 30 degree times the value of force. What's the value of force component? 300 sine 30. Positive or negative? Take your right hand, finger goes to R. The palm should show the direction of force. Where is my thumb going? Inward, so it's negative. So you put a negative here. Right? Is there anyone that don't understand this yet? I assume that you all know how to do that. Because look, this is the easy part of the course. In a week or two, we're going to go to the equilibrium and we're going to talk about the frame analysis. And if you don't know how to do that, this is the most important part. Computing the resultant moment. If you don't know how to do that, you're going to face up with a lot of difficulties. So I would recommend, now I assume that, because I didn't get any feedback, I assume that you all know how to do that, right? If you don't, I would recommend just go grab the book and start reading and solving the examples. Because this course, if you don't solve the examples, no matter how smart you are, you won't be able to solve the problem. You won't be able to be successful, especially if your major is mechanical/civil. This course is extremely important because everything you do after this is going to be based on this course. This is the most fundamental course. Do you have any questions?
Yeah. Why don't you use the 300 cosine 30
Right now, we are just doing this component. We haven't reached to that.
Oh,
I'm just this is a side. At the middle of the problem, I'm just making a big parenthesis and give you an important message that, look guys, this is the easy part of the course. We should be able to understand and do this very, very quickly, like this. You shouldn't even draw, right now, on the next example, I don't even draw the components. I just do it in my mind. Right? So, now going back to the question, now I'm done with this component. So this is the one that I moved. 300 sine 30 times the effective moment arm, and it was negative. Now I go and do this guy, the y component, as she said. So where should I move it? Down. Yeah, you bring it down. So you start moving it from here, you bring it down, such that it becomes, so you bring it right here. See that? You bring it right here, and here is normal to the distance. So this is your R, position vector, and this is the force component, right? So what's the moment arm? The moment arm is equal to from here to here. What's that value? 6 plus 6 sine 30 times the value of force, which is 300 cosine 30 degrees. So 6 up to here, from here to here, 6 plus this one is 6 sine 30, right? From here to here. Times the value of force. The value of force, 300 cosine 30. That's the magnitude of force, right? Positive or negative? Positive. Why? Take your right hand. Every single time you have to take your right hand. Finger goes to R. Now your hand is fixed. You can't do this or this or this, right? Your hand is fixed. You can either do this or this, right? Now the palm is showing force. Where is the force going? Down, right? So your thumb is showing the direction of the moment, which is outward, positive, because if this is your X and this is your Y, your Z is outward. Positive Z is coming out of the whiteboard, right? So that's it. That's it. That's if you do, look, even if you don't put this in the calculator, right? I'm going to give you 100%. If you have all this numbering correct, all the signs and everything, right? Because everybody can put this in calculator, even a high school kid can put it in calculator and give you the value, right? The important thing is understanding. Now, if I want to use cross product, how can I find it? Well, the resultant moment is a vector like that. Here we talk about magnitude, right? Is a vector is equal to sum of resultant moment Ri cross Fi for each force. Right now, we have 2 forces, right? So that's going to be R1 cross F1 plus R2 cross F2. What's the value of R1? R1 is, or Ri, whatever I distance is a position vector starting from reference point and ending at the point that force number I is acting on. Now force number 1 is acting on this point. So R1 starts from reference point and ends at the point that force 1 is acting on. So let me draw it. R1 is this. This is R1. So what should I write for R1? 6 plus 6 sine 30 with negative I plus 6 cosine 30 J. But my reference is right here, right? This is X positive, Y positive. I put it at a reference point. This is a reference point. So this point, the X is negative. 6 plus 6 times sine 30. The Y is positive 6 times cosine 30. So that's your R1. What about R2? R2 is a vector starting from reference point and ending at point that force number 2 is acting. Where is force number 2 is acting? The same. So R2 is R1. Alright, they're exactly equal. What about F1? Cartesian form of F1. F1 what should I write for Cartesian form of F1? You have it right here. X component, Y component. What should I write?
300 sine
300 sine 30 I, then 300 cosine 30 negative J. You see? This is going down. You see, this is IJ. It's going down. Right? So this is F1. What about F2?
Negative 200.
Negative 200 I. And this F2. Now let's put all things together. So I write it here. The resultant moment is going to be R1 cross F1, moment from force 1, let's call this M1, plus R2 cross F2, moment due to force F2, M2. That's going to be R1 is simply 300 sine 30 I minus 300 cosine 30 J, the entire thing cross F1, and F1, no, this is R1, R1 is this, I use F1 for R1. Is equal to, I should use this guy, so you get 6 plus 6 sine 30 I plus 6 cosine 30 J. That's your R1, right? Cross F1. F1 is what? F1 is this guy. 300 sine 30 I negative 300 cosine 30 J. Alright? Plus R2. So let me show you this is R1. And this guy is F1. So we cross product. Then we go to R2. R2 is R1. So I just use 6 plus 6 sine 30 degree I plus 6 cosine 30 degree J. So this is also R2 cross F2. F2 negative 200 I. That's long, isn't it? F2. Now, this is the time that you really appreciate the advantage of method of moving forces. Because if you want to do this, just writing it down, it's a headache. Now look, you have to expand this distribution or put it in a determinant. And then do it same for this. And then at the end, add I with I, J with J, K with K. In fact, at the end, you get what? You should get the same value here. Check it at home. Optional homework, you don't need to turn it in. Just check it at home. You should get exactly the same result. Right? Okay. Now let's go to talk about couple moment. So, what is a couple moment? Now we want to talk about a couple moment. All right. Couple moment is generated by two equal force vectors acting in the opposite direction. So let's say this is a structure that you have. It's a beam. We will talk about this particular structure later in details. We're going to have some examples. In roller here. Also, we're going to talk about this connectivity. What's a roller? What's a pin? Later on when we do free body diagram. But for a moment, let's say we have a structure. Now, let's say we have a loading. There is a force acting at this point, 2 kilonewton. And there is another force exactly equal, but the opposite direction. So 2 kilonewton, but it's going the opposite direction. Let's say this distance is 2 meters. And this distance, let's extend this a little bit. Right? I don't want to be symmetric so you can understand how it is. So let's say this is point A, this is point B. That distance is 2, this distance is 11, and this distance is 4 meters. So here is a beam, you pin at the point A, you pin it to the ground. So look, this can rotate around this point, but it cannot move, right? Pin connection, we will talk about it. This point is on a roller, so you can easily slide. There's no friction here, right? So now I have two forces, 2 kilonewton. One is going down, one going up. The distance between them is 2 meters. The distance from this force to here, point A, is 4, and the other one is 11 meters. What I ask is find the resultant moment, or M resultant with respect to point A. That's the first question. Now, using this, I want to introduce the concept of couple moment. In fact, this is a couple moment. There are two forces exactly equal, opposite direction, right? So what is the property of couple moment? We are going to discuss this example to understand that. So find the resultant moment of these two forces with respect to point A. Let's start with 2K here from left. So what should I write? 3 steps: decompose, move, compute. It's already decomposed. It's in the y direction. So you don't do a step 1. Step 2, move it. Well, it's already normal with respect to point A. You see, they are already perpendicular. You see that? So you don't need to move it. Step 3, compute the moment. So what should I write for the moment of this guy with respect to A?
4 times 2.
4 times 2K. Positive or negative? Positive or negative?
Positive.
Thank you. Now let's go to the next one. What should I write for that? This one.
11 times 2.
From this point A.
Oh,
6.
6.
All right, 4 plus 2 times
2K.
2K. Positive or negative?
Positive.
Negative.
You see,
Oh, yeah, it's coming,
R
yeah,
is
yeah.
from the reference point to the point that force is acting
So
on.
it's
So
negative.
this is R, F, Newton, negative. So as you can see, this 4 2 times 2 cancel out with 4 times 2. So at the end I get negative 2 times 2K, negative 4K, Newton meter. Right? Now, as you can see, if I ask you what's the resultant force in the y direction, what's the resultant force in the y direction? Not moment, what's the resultant force in the y direction? 0. What's the resultant force in the x direction? 0. You see, everything is 0. The only thing that remains is a moment. 4K negative, like this. So that's the reason we say couple moment, because only the moment matters. The force does not matter. So sometimes you see they put something like this. Instead of showing these two forces, right? They just show a notation like that and write the value 4K Newton meter. Right? So they don't show these two forces and the distance. This is 3 information. Force 1, force 2, and the distance, right? 3. They simplify that. They don't show these two. They just show you something like that. It shows you kind of torque, twist, rotation, right? And they give you just a magnitude, 4 kilonewton. If this is 4 kilonewton, this way is negative 4 kilonewton. Right? If they graphically show the direction. So when they say couple moment, in fact, they're talking about two actual physical loads with some distance, but they don't show it to you. So when you treat couple moment, you just add it to the resultant moment. You don't do anything with the forces. When I say find the resultant force, you don't add this to the forces. It's just a pure moment, right? The next property is couple moment is the same. Let me write it here. Couple moment. Couple moment is independent of the reference point. Couple moment is such a universal concept. It's independent of reference point. The value is exactly the same, no matter what reference point you take. Let's take point B as a reference point. And let's find the resultant moment around B. I'm going to write it here. Moment resultant with respect to point B. Let's start with this guy. What should I write?
11.
11 times
2K.
2K, positive or negative? Positive. And then the next one, 2 plus 11 times
2K.
positive or negative?
Negative.
Thank you. Now, as you can see, this 11 times 2K cancel out, and what you get is negative 2 times 2K, negative 4K. So isn't that exactly the same when we took 0.8? So it doesn't matter what reference point you take, the moment is same. This is only valid for coupled moments, not any fourth configuration, only coupled moments. So instead of wasting your time with showing 2 force and the distance, you just drop this, and at this point, you just put something like that. It's a curved arrowhead, right? It shows the direction of rotation, and say 4K, the value, 4K. Look, I don't say negative 4K, I say positive 4K, but I show you the direction of negativity. If you put negative 4K and you show this direction, that means just reverse it, it's going to be opposite, so it's wrong. Either use negative or graphically show the direction, either way, right? Okay, now let's go to a more complicated problem. Is that visible in the camera? Can you see that?
Mhm.
All right, let's say this is 3 kilonewton force. This is 4 kilonewton meter. This is 2 kilonewton. And this is 9 kilonewton. We're tolerant to that. So, here's where I should have this better color for the beams. So this guy, pin, this one is pin, the ground, G and D, that's ground. Then this guy is on a roller. Oh, this pin is also. This distance from here to here is 4 meters. From here to here that's 2 meters. Here to here 2 meters. Here to here 3 meters, and here to here 1 meter, and this length half, and the angle is 45 degrees. Right? So here, this structure is called frame. What is a frame structure? When you get beams, you know, I-beam, I'm pretty sure you all know what I-beam is. I-beam is a component used, most frequent component used in construction. It's not necessarily constructing a building, it's also used in the small designs, mechanical engineering. It's not necessarily construction necessarily. It can be used in a variety of different things, right? So the cross section is like that. So consider, look, if you look at it from the side, then you see here, there are things like that. The cross section is like that. You see, it has 4 lines, right? If you look at it from the side. So what they do, they build the structure using by connecting the beams together, right? There is another structure is constructed by connecting rods together that they don't accept shear load, but this one accepts shear load. So later on we realize the analysis is more complicated than truss. Truss is easier because the load is always axial. Right? Right now we're not talking about that. Right now the question is find the resultant moment with respect to point. Let's say this is point B, and this is point C, this is point A, and this point B. Right? Find resultant moment with respect to point B. Just the value of resultant moment. So what should I do? Well, I can either use cross product as I did before, or method of moving forces. Which one I use?
Net forces.
Yeah, that's the easy one. You want to do things quickly as an engineer, right? So let's start with this guy. What was the first step?
Break it up.
Break it up, right? X and Y component, right? So I don't draw it here. I just do it in my mind, right? So what would be the X component? Let's say this angle, we need also this angle. This angle is also 30 degrees, right? What would be the X component? 3K sine 30 times moment R with respect to B. Well, we don't need to move it. It's right here. Right? The X component is like that. It's orthogonal. So what's the moment R? 4. Positive or negative?
Positive.
Positive. Now let's go to Y component. So Y component move it. You see it's going through that point, so momentum is 0. You see that? There is no way that this can generate the rotation or twist around B because it's going through B. So you don't do anything with 3K cosine 30. You only have 3K sine 30. The Y component doesn't generate any movement. I'm done with this. I go to the next one. What should I do with this? That's right. It's a couple moment. You don't need to move it. You don't, because it's universal. It doesn't matter what reference point you use. It's same, right? So I just add it to this. So I write 4K plus or minus. Take your right hand. You see the direction of rotation is plus. Right? So you got rid of this guy, you got rid of this guy. Let's just not make it too, you know. We have enough notation on the figure. I don't want to make it more complicated than what it is. Now let's go to this guy. The first step, break it up. It's already broken. It's in Y direction, right? Then move it. Step 2. Where should I move it?
To C. Oh, down.
Right? Look, you can't move it sideways. You remember we proved it. You can't move it sideways. You can always move it along line of action. So where is the line of action?
Right there.
Right here. So you move it down somewhere here. And at this particular point, you see this intersection? This component becomes This component become normal. This is your 2K. This become normal to the moment arm. So that's your moment arm. So what's your moment arm? 4. So here, I write it here, 4 times
2K.
2K. Positive or negative?
Negative.
Look, where is your R? R from here to here.
Positive.
This is R. Finger goes to R. The palm should show the direction of force. Where is the direction of force? Down. Right? So the thumb would show positive, outward. Outward is
Why is it
positive.
4 and not 6?
Positive 2 times
1 plus 3.
4 times 2, positive. So what was the question again?
It's 1 plus 3.
One,
Okay.
it's 1 plus 3. It's
Okay.
4 times
Okay.
2. Positive. You see that?
Mhm.
Did you have a question?
No, mine was the same, but yeah.
The same question. Okay, all right. Now, let's get rid of this because this makes it very. All right, extra thing, you don't need extra things here. All right. Now, I got rid of this too. What about this guy?
Break it up.
Break it up. First step. So if I break it up, I want to show this guy here. So you get 2 components. You get 1 component like that, and 1 component like this. You see? One is down, one to the right. So what's the value of this guy?
9K.
9K cosine 45. And what's the value of this guy?
9K sine.
9K sine 45. Alright? So break it up. Step 2, move it. So let's move this guy. Let's start with this guy. Where should I move it?
Down.
To get normal with this. Down. That's right. So if you move it down, right? And this is this line, the intersection. You see that point? This intersection is the point that you move that force. So it becomes normal. So this is your R, and that's your value of force. So what should I write here? The value of the moment arm. What's the value of moment arm? 1 plus 3 plus 2. 1 plus 3 plus 2 plus, you start from here, right? 1 plus 3 plus 2 plus 3 times cosine 45. Moment arm times the value of force. What's the value of force? 9K sine 45. There you go. 9K sine 45. Positive or negative? Positive. Now let's go to the other component. It's already broken out. So what should I do then? Move it. Step 2. Where should I move it?
To the right.
To the right. So if you move it here, then you see it's going to be normal to this R. So what's your moment arm?
4.
Uh,
Because 1 plus.
No, it's not 4.
Is it 1 plus 3 is 4.
Is this length, whatever it is, minus the y projection of this.
So 5 minus 3.
So 2 plus 4, let's write it here. 2 plus 4 is from here to here, right? Minus 3 cosine 45. Moment arm times,
shouldn't that be sine?
yeah, sine. Times the value. What's the value? 9K cosine 45. Right here. 9K cosine 45. Positive or negative?
Negative.
Negative. This is R, right? And the force is going this way. So you take your hand, fingers go through R. Palm will be showing the force. Your thumb will be showing the direction of movement, which is negative. That's it. You put in the calculator, you get a value, right? So this is a pretty complicated example. We're going to have lots of examples like this in the next section when we do equilibrium.